So let us see about uncontrolled rectifier. What is uncontrolled rectifier? It is nothing but a diode rectifier, because diode is the uncontrolled device. So in that we will see about the half-wave rectifier with R load and L load, and all the expressions necessary for analysis of the rectifier are derived. So what is a rectifier? So it is a power electronic converter, so which converts AC voltage to DC voltage. So AC, it can be of single phase or three phase, that can be converted into direct current quantity. So this is the classification of a rectifier. So rectifier can be of single phase or three phase. So in single phase, you have uncontrolled rectifier, half controlled rectifier and fully controlled rectifier. So uncontrolled means diode rectifier, fully controlled means thyristor based rectifier, half controlled is a combination of diodes and thyristor. So in uncontrolled rectifier, you have half wave and full wave. So in that we will see about half wave in this video. So if you see the three phase, you have same classification: uncontrolled, half controlled and fully controlled. Again you have half wave and full bridge. In fully controlled also you have half wave and full bridge. So this is a single phase uncontrolled rectifier. So it is of two types, half wave rectifier and full wave rectifier. As far as rectifier is concerned, the output voltage and the current of the rectifier are greatly influenced by the type of load. It means that whether you are supplying a resistive load or you are supplying a battery or an inductive load, depending upon that your output voltage and current will change. So we will analyze the performance of this rectifier for different type of loads, namely R load, L load, RL load, and if this RL load has a freewheeling diode, what will be the performance? And in case of a RE load, here E refers to battery. So in this video, we will see about R load and L load, half wave rectifier with R load and L load. Let us see about the single phase diode rectifier. So before going to the topic, we should know certain things. So it is single phase diode rectifier. So taken a single phase supply here. So that is given by Vs is equal to Vm sin omega t, and a diode rectifier. So this is the diode and this is the load. So to draw this waveform, Vs is equal to Vm sin omega t. So what is here? Omega t is here. So x-axis should be omega t. And this voltage Vs is given here. And this is a sinusoidal waveform. So draw a sinusoidal waveform. So this value should be pi and this is 2 pi. Because sine 180 is 0 and sine 2 pi 360 is also 0. So we have drawn the waveform. Then what is the magnitude of this waveform? That is Vm. So this is Vm. So Vm is the magnitude. So Vm sin omega t is your supply source waveform. So only if you know to draw this waveform, you can study the full subject power electronics. Otherwise, you cannot study any topic in power electronics. Okay, so now what is this 2 pi? That is called one cycle. So this is called one cycle. Now let us come to the topic, half wave rectifier with R load, and supply voltage is given by Vs is equal to Vm sin omega t. So let me draw this waveform sin omega t, and this is drawn for one cycle. Let me repeat it for second cycle also. Okay, then remaining waveforms what we should draw is V0, load voltage, load current and voltage across the diode. So when the diode is forward biased, so when it will be forward biased, when the supply voltage is positive, that is during the past half cycle, diode will be forward biased and it conducts the current I0 which flows through the load. So V0 is equal to I0 into R. So when this diode conducts, considering it to be an ideal diode, it is almost like a short circuit. So supply voltage is equal to the load voltage because both are in parallel. So this Vs is in parallel across the load. So Vs is equal to V0. So during past half cycle, Vs is equal to V0. So we will draw the waveform. Vs is V0 equal to Vs. So during negative half cycle, when the diode is reverse biased, this will not conduct. So if it doesn't conduct, it means that circuit is open, so no load voltage. So output voltage is 0 here during the negative half cycle. So it is repeated here also. Now to draw I0, so what is I0? This is resistive load. So it is very simple. Ohm's law, apply Ohm's law. I0 is equal to V by R. So we will get Vm by R magnitude, but waveform shape will be same. Only magnitude will change. This is applicable only in case of resistive load. And next waveform what you have to draw is Vd. So what is Vd? Voltage across the diode. Why this voltage is important means, if you want to design any circuit, you have to choose the rating of the diode, because diode will be available in different ratings, 50 volts, 100 volts, 1000 volts. So you should know what voltage will appear across the diode so that it will not get damaged. So for that you should know what is the voltage across the diode waveform. So when a diode is conducting, the voltage across it will be always 0 or 1 volt. Okay, let me take it as a ideal diode, so voltage is considered to be 0. So during this period it is considered to be, so this period it is considered to be 0. During negative half cycle, when the diode is not conducting, that is when it is open, what happens? This voltage will appear across the diode. So how to find? Vd is given by, so this is just a Kirchhoff's law, or you can directly write it. Vd is nothing but Vs minus V0. Okay. So what is Vs? This waveform V0 is here. You subtract these two, you will get 0 here. So when you subtract during this period, this is minus Vm minus 0. So you will get minus Vm here. Again 0 and minus Vm. So this is the minus Vm is the peak voltage that will appear across the diode. And one more thing we have to note down here is output voltage. If you see in one cycle, so this is one cycle, you have only one output waveform. It means that it is called one pulse rectifier, meaning that only one voltage pulse is appearing every half cycle. So half wave rectifier is also called as one pulse rectifier. So when we see the output voltage, it doesn't appear to be a DC voltage because rectifier converts AC to DC. But this doesn't look as a DC waveform because it contains this AC component. So it is necessary to find the average value of this waveform so that we can say that this is the output voltage of my rectifier. So we will find the average value for this waveform. Okay, so average value of output voltages, this is a standard formula which have to learn. Very simple. So we are finding the output voltage. So V naught for a total time period T. So this is the time period T. So 1 by T integral of 0 to T f of t into dt. Here f of t I have taken as output voltage. It can be any other waveform also. So 1 by 2 pi integral of 0 to 2 pi V naught into d of omega t. So V naught is Vm sin omega t. So in last waveform itself we have seen V naught is equal to Vm sin omega t. So integrate this one. So now you can see that 0 to pi you have waveform. For pi to 2 pi there is no waveform. So this period you can discard. So you change the limits to 0 to pi into sine of okay. Now integrate integral of sine omega is minus cos omega t. So apply the limits, you will get Vm by pi. So your average voltage is now Vm by pi. So this is the average voltage. Similarly, so let us find the RMS voltage of the output waveform. Same output voltage waveform. So VRMS is, what is RMS? Root mean square value. So in formula, this is also standard formula. In formula you have root, okay, root, then find the mean. So mean is 1 by t, square value. So function you square it. So this is the RMS value, root mean square value. So you apply the same thing. F of t is V naught. So V naught is nothing but Vm sin omega t, the whole square into dt. So when you have a sine square term, you cannot integrate as such. So sine can be replaced by 1 minus cos 2 omega t by 2. And you solve it, you will get Vm by 2. So this is the RMS value. And you can find that VRMS will be always greater than V average. We have already seen the output voltage waveform of a rectifier. It is not pure DC, it consists AC component also. So ripple factor is a term used to measure the deviation of the output voltage from an ideal DC value. So ripple factor is given by this formula. We have already derived for RMS and average value. So substitute these values, we will get around 1.21. This indicates that the ripple factor is very high or the output voltage is not a pure DC waveform. So this rectifier is rarely used. So let us see about the second type. So next is half wave rectifier with L load. So this is completely different from the R load because R is a energy dissipating element where L is a energy storing element. And the other thing is when you pass a current through the inductor, it stores the energy, and this current through an inductor cannot become zero instantaneously. So you should provide some path for the current to flow. So that the energy stored in this will be released. The other thing is the average voltage across an inductor is always 0, and VL is given by L into di by dt. So this di by dt is the rate of change of current. So if it is positive, voltage will be positive. This is the voltage across the inductor, that will be positive. If this is negative, voltage will be negative. So when rate of change of current will be positive means if it is increasing, that is you take the difference between this instant and previous instant, it is increasing, so di by dt will be positive. Suppose if it is decreasing, like and this instant to this instant it is decreasing, so in that case di by dt will be negative and VL will be negative. So now let us go to the topic. So we have drawn the supply voltage and now we want to draw the output voltage. So during positive half cycle of the supply voltage, diode is forward bias and it will conduct. So output voltage will follow the input voltage. No problem. So during negative half cycle, actually what happens, when this diode is about to stop conduction, the current through this inductance, current is flowing through the inductance and it cannot come to zero immediately. So if diode stops conduction, current should come zero, but this diode has to flow. So this diode has to conduct. Okay, so since this current has to flow, diode will be conducting. And the other thing is, here when you have the negative supply voltage here, and the voltage is negative, di by dt will become negative because current will also start to decrease. So in that case, VL will become negative. So if VL this side negative and this side positive, it means that cathode will be more negative when compared to anode, or whenever anode is more positive with respect to cathode, diode will be forward biased. So in this case, diode continues to conduct. So output voltage will be always equal to the supply in case of a pure inductive load. Okay, so this condition will satisfy only for a pure inductive load. So now let us find what is the I0 waveform. So we have found V0 waveform. Now we will find what is I0 waveform. So to find I0 waveform, we have to write the equation. So V0 is given by L into di by dt. That is V0 is equal to supply voltage. So that is Vm sin omega t. So now you find I0 from this equation. So this is a differential equation. So integrate on both the sides. So you will get I0. So I0 is equal to this thing plus 1 constant. So you simply integrate sin omega t, you will get cos omega t. So integration is with respect to dt. So you will get 1 omega time here. Now you apply, you have to find what is this constant A. So for that apply the boundary condition. So what is the boundary condition? So we know at the initial stage, that is omega t equal to 0, I0 equal to 0. So apply this and find what is A. So in this equation you put I0 equal to 0 and instead of omega t you put 0. So you will get what is A. So this A you substitute in I0. So it will become like this. Solve this one, you will get this one. So this is the I0 equation. So now let us draw the I0. So now we have already derived for I0. So we will find the we will draw the output current waveform. Okay. So at omega t equal to pi, what should be the value of I0? You substitute omega t equal to pi here because cos pi is minus 1. So if you find the value, you will get this one. And again another limit, omega t equal to 2 pi. What is the value of current? I0 is 0. So you draw this waveform. Okay, so this is the value of I0. Now we have to find what is VD. So VD, we have already found average value is 0. VRMS we have found. If you find VD, we know that diode is always in conduction. So it is 0. The waveform is 0. It's just a 0 line because always diode is in conduction. So the points to remember here are: rectifier is a power electronic converter which converts AC voltage to DC. The output voltage and the current mainly depends upon the type of load connected to it. Half-wave rectifier is also called one-pulse rectifier because in output only one pulse exists in every cycle. And the output voltage of the half-wave rectifier is ripple is very high, so it is rarely used. So these are some of the references. And if you like the video, do subscribe to our channel. Thank you.